Alright guys, today we're going to be working on the Unit 1 review just to make sure that we have all of our questions answered before we actually take our test. So, as we go through these, go ahead and pause the video as you need to, and then I'll just be going through them afterwards. But take your time, pause the videos, take as much time as you need on each question, and then you'll be able to check your answer afterwards. So, let's go ahead and get started. So, go ahead and try and solve these three problems, and then unpause the video whenever you're finished for the explanation. Alright, so first off, we have ray EC union ray FA. So a union is creating something new. So if I look at this, if I have ray EC, so it starts at point E and it goes through point C, and also ray FA, starting at point F and going through A, what they create is they create this line here, this blue line. And this blue line can be named lots of different ways. I can call it line AC, I can call it line FE if I'd like, lots of different ways to name this thing. Next, we have the intersection of ray EC and ray FA. So again, we're using these same exact rays once again, but this time we have an intersection, meaning where they cross over each other. So I did this one in red, again, same exact rays, but where's the crossover at? Well, the crossover is from point F all the way to point E. That's where they're overlapping each other. Anything past that no longer works. So therefore our answer is segment FE. And it's very important that this is a segment. As you saw earlier, there were some arrows here, but just make sure that you get rid of those. It should be a segment, should have endpoints on either side, much like FE does. Then lastly, ray BA union ray BE. Well, these are two different rays, and they both share a common endpoint, B. Now, these aren't opposite rays like we saw in the first part with this blue one. These aren't opposite rays, so they create an angle. So I have angle ABE. I can also call it angle EBA or angle 1. I cannot call this angle B because the whole thing would be angle B. So keep that in mind. We need to be very specific when we're naming these angles. So this would be angle ABE. All right, next up. Go ahead and pause the video, and then we can go through this one whenever you guys are ready. All right, looking at number 2. We're converting 46 7/8 to degrees, minutes, and seconds. So I'm going to go ahead and take that 7/8, and I'm going to multiply it by my conversion rate of 60, because I know 1 degree equals 60 minutes. So if I multiply it by my conversion rate, 7/8 of a degree will give me how many minutes are in that 7/8. So that'll give me 52.5 minutes. Now again, I'm going to take that 0.5. I'm going to take that 0.5 and I'm going to multiply that by 60, because I know 60 seconds are in 1 minute. So therefore, we end up with 0.5 times 60, which gives us 46 degrees. That doesn't change. 52 minutes. Again, that doesn't change once I got the 52. And then 0.5 times 60 gives us 30 seconds. For part B here, change 132 degrees and 6 minutes to degrees. Well, I'm going the opposite way. I'm trying to get it all as degrees. I need a decimal. So therefore, I'm going to divide my 6 minutes by my conversion rate. Because I was multiplying earlier to get it to minutes and seconds, I do the opposite to get it to degrees. So dividing 6 by 60, we get 0.1. I take that 0.1 and I add it to the 132 degrees that we already have, which gives me 132.1 degrees is our answer. So 132 degrees in 6 minutes is the same as 132.1 degrees. All right, next up we have a ratio problem. Go ahead and pause the video and we'll go through this together whenever you're done. So looking at this, the measures of angle 1, 2, and 3 are in the ratio of 1 to 3 to 2. And again, that's relating with the angles. Angle 1 is 1, angle 2 is 3, and angle 3 is 2. Find the measure of each angle. Well, first off, I see the straight line on the bottom. That signifies that we have a straight angle happening here, meaning all three of these angles combined equals 180 degrees. So if it's in a ratio, I give each of my ratios a variable. So it's going to be 1x, 3x, and 2x respectively. So I went ahead and I marked those in my picture. Angle 1 is x, angle 2 is 3x, and angle 3 is 2x. Now, again, if we combine all three of these angles, it equals 180 degrees. Angle addition postulate. I combine x, 3x, and 2x to give us 6x equals 180, so therefore x equals 30. but we're trying to find the measure of each angle. So I take this 30, I plug it back in for x, and that gives us angle 1 is equal to 30 degrees, angle 2 is equal to 90 degrees, and angle 3 is equal to 60 degrees. And those are our 3 angles. All right, next up we have number 4, which is a proof. So go ahead and pause the video, and then whenever you're ready, unpause it and we'll go through it. All right, so for this one, we're given diagram is shown. We want to prove angle EFG is congruent to angle HJK. Now looking at our diagram, these are both straight lines, meaning that they'll create straight angles. So my first statement is diagram is shown. Well, that's given to us. So I just write given for my reasoning. Number 2, angle EFG, this line, is a straight angle. Well, we can assume straight angles from diagrams. That's something that we learned when we were working on 2-column proofs. So I can write assume from diagram for both number 2 and number 3, because again, we're focusing on straight angles for both of these. And we're assuming both of them from the diagram. Lastly, angle EFG is congruent to angle HJK. The reason that we can say this is our shortcut that we learned when we were doing our 2-column proofs. I can write if 2 angles are straight angles, then they are congruent, or I can say all straight angles are congruent. That's the shortcut that we found out while we were working on straight angles earlier. So keep that in mind. At this point, our proof is now finished, so we can draw our box if we'd like, and you guys are good to go on this one. All right, next up is number 5, a midpoint problem. Go ahead and pause the video if you need to, and then we'll go through it. All right, so looking at number 5, it says find the coordinate of C. C is the midpoint of segment BD. So the first thing I need to do is find the distance from point B to point D. Now I can just start counting and be like, okay, -7, -6, -5, or I can take the absolute value of point B, which is -8, and subtract point D from it, 2. Now that will give me the absolute value of -10. Now the reason I have these absolute values here is because it doesn't make sense to have a negative distance. I can't have a negative distance, only a positive distance. So therefore, the absolute values make sure that I keep my value positive. So at this point, I know that the distance from B to D is 10 units, which means that point C should be 5 units away from B, or 5 units away from D. Because again, C is the midpoint, so it should be equal on both sides. Both sides should be congruent here. So if that's the case, and I start at point B is at -8. If I go 5 to the right, that's in a positive direction from point B, I'll end up at point C. So -8 plus 5 gives me -3. Likewise, if I started at point D, that's at +2, and I move left to point C, that means that I'm getting smaller and smaller, a lesser amount. So that'd give me -5 plus 2, or 2 minus 5, because I'm moving to the left. Again, that'll give me -3 as an answer, so regardless, we end up with point C being at -3. Sorry about that. So point C is at -3. We could also find out point A if we have a little bit more information on this problem. All right, next up is number 6, a trisection problem. Go ahead and pause the video if you'd like and go through this one, and then we'll go through it together. So, for this problem, if I know angle TOP, the whole thing is equal to 40.2 degrees, and I know that ray OR and ray OS are dividing rays because they are trisecting our angle, meaning that's cutting into 3 pieces, then I can take that 40.2 degrees and divide it by 3, because it's being cut into 3 equal pieces here. Well, that will give me 13.4 degrees per angle. So each of these angles is 13.4 degrees. Now, if I wanted to convert it to degrees, minutes, and seconds, I can do that. So it's 13 degrees and 24 minutes. Or I can also say it's 13 degrees, 23 minutes, and 60 seconds. So again, it depends on what type of answer they're looking for, and the problem will be very specific with that, but these are all equivalent answers. They're all the same thing. Other than that, again, we're looking for angle POR. That's just 1/3 of this entire angle, so it's just going to be the 13.4 degrees. If it's asking for POS, then I'd have to do 13.4 plus 13.4. All right, moving on. We have the angle formed by the hands of a clock at 11:20. Go ahead and pause the video if you'd like, and we'll go through this in just a minute. All right, so at 11:20, the first thing I'm going to do is draw my clock. So I have my clock here. It's at 11:20. Now, I know that there's 30 degrees between hour, The way that we get that is 360 degrees total divided by 12 hours gives us 30 degrees for every 1 hour. Now, we have 30 degrees between each of these, except between the 12 and the 11, because that's where our hour hand's in between. So it's somewhere in between the 11 and the 12. Now to find out how far we've moved past the 11, I'm going to take my minutes, it's at the 4, and there's 12 total numbers on this clock. So I do 4 divided by 12. Well, 4 divided by 12 is 1/3, and I multiply that by 30, because if I'm moving 30 degrees per hour, and that minute hand has moved 4/12 of a full rotation, then my hour hand has moved that fraction of 30 degrees. So therefore, 1/3 times 30 gives me 10 degrees. So we have moved 10 degrees past 11 o'clock. So therefore, I still need 20 degrees to get to 12. And that 20 degrees is what's included in this angle that we're looking for. So therefore, we have 30, 60, 90, 120, 140 degrees as our final answer for the angle formed at 11:20. All right, next we have another segment ratio problem. So go ahead and pause the video if you'd like, and we'll work through this one in just a minute. All right, so for this one, we're trying to find the length of WX. So from W to X. Now, I know that the whole thing, WY, is 25. And I know that there's a ratio of WX to XY. And that ratio is 3 to 2. So again, if I have a ratio, I'm going to give variables to both. So WX would be 3X, XY would be 2X. And the whole thing is 25. So I can do segment addition postulate here. So I have 3x plus 2x equals 25, the whole thing. From here we get 5x equals 25, so x is equal to 5, and we solve for x. But again, we're looking for the length of wx. Wx is equal to 3x. So I'm going to take this 5 and I'm going to plug it in for wx, so I have 3 times 5. Well, 3 times 5 is 15, so wx is 15 units in length. And that would be our answer. All right, here's our next problem. The diagram shows Kara's watch. If Kara cannot go home until 4:15, so the minute hand needs to travel around, how many degrees must the hour hand travel before she can go home? So we want to know how much our hour hand travels based upon how many minutes have passed. So go ahead and pause the video if you'd like, and we'll go through this in just a minute. All right, looking at this one. Kara's watch is currently at 3:35. And she can go home at 4:15. That means that the minute hand has to travel 5, 10, 15, 20, 25, 30, 35, 40 minutes. So it needs to travel 40 minutes until she can go home. Well, we can determine how much an hour hand has moved in 40 minutes. The way that we can do that is we take that 40 minutes and I divide it by the 60 minutes in an hour total, because I know that my hour hand moves 30 degrees per hour. So if I do 40 over 60, and again, that's focusing on minutes, that means that we've moved 40/60ths of an hour, or 40/60ths of 30 degrees. Well, reducing 40 over 60 gives me 2/3, so therefore my hour hand has moved 2/3 of a full hour. Well, if a full hour is 30 degrees, that means that it's moved 20 degrees from 3:35 to 4:15. The hour hand has moved 20 degrees. All right, next up, number 10, we are going to be looking for restrictions on this angle. So go ahead and pause the video, try this one out, then we'll go through it. Looking at this one, we can see that angle Q is obtuse. Well, what that means is that angle Q must be larger than 90, but less than 180. So our restrictions on Q are between 90 degrees and 180 degrees. And again, it can't equal either one of these, because if it's equal to 90, it's a right angle. If it equals 180, it's a straight angle. So we also know angle Q is equal to 2x minus 28 degrees. So I can substitute 2x minus 28 degrees, this expression in, for angle Q to find out my restrictions on the variable x. This will give me 90 is less than 2x minus 28, that's the substitution, which is less than 180. Solving for x, we end up with 118 is less than 2x, which is less than 208. So therefore, dividing all three sides by 2, we end up with 59 is less than x, which is less than 104. So therefore, x must be a value somewhere in between here in order for this angle to remain obtuse. If my value of x is 59, then that means that I have a right angle occurring. if my x value is 104, that means I have a straight angle occurring. And if it's anywhere in between these two values, then that means that I have an obtuse angle occurring. So those are the restrictions on the value of x so that Q can remain an obtuse angle. All right, here's our final problem for the day. Go ahead and answer these true or false questions. You can pause the video real quick if you need to, and that way we can go through them afterwards. All right, so first off, it is possible for two planes to intersect in a point. Well, if I'm dealing with planes, and we've talked about this in previous videos, if I'm dealing with planes, I know that planes must intersect in a single line, not a point. So the first one is false, because again, they intersect in a line. And these planes go on forever, they never end, so this line is the same exact thing, it never ends either. Then our other statement, if a line is perpendicular, so I draw this perpendicular line here in purple. If this line is perpendicular to a plane, then the line is perpendicular to every line that lies on that plane. Well, I have this purple line that's perpendicular, and then if I have any lines going through my plane, they will all remain perpendicular to this line because they all lie on the plane. They're all contained in the plane. So no matter which line goes through this plane, those lines will all be perpendicular to the line going through it. That's perpendicular to the plane. So number 2 would be a true statement because every single blue line here will remain perpendicular to the purple line because the purple line is perpendicular to the green plane, which holds all of the blue lines. All right, that is it for this video. We have now finished covering Unit 1A, Introduction to Geometry. Make sure that you guys review this video at your leisure, try out all these problems, and make sure that you're getting them all right. If you have any questions on this, please feel free to reach out to me. You can comment below as well. Other than that, thank you guys so much. I hope that you guys all have a great day. I'll see y'all later.